Hi, everybody, and welcome to the... Sorry, I'm just messing with you.
Hey, everybody, and welcome to the Ruby Rogues podcast. This is Charles Max Wood, and this week on our panel we have, in no particular order, James Edward Gray. He is the author of the Faster CSV library, as well as the TextMate book. He tweets at JEG2, and he's not on drugs this week. Yay, James.
Yay for less drugs.
We're so proud of you.
We also have David Brady. He is the author of the Tour Bus Library. He hosts ADD Casts. He blogs at heartmindcode.com. And he is starting his own programming company at Shiny Systems. And you can find him at shinysystems.com. Is that right?
No, shinybit.com, but don't go there because that website looks awful. Because the first person we're going to hire is a web designer.
Yay. So he's hiring. So if you want to work, talk to him.
Yep.
All right. And then we have Josh Susser. Josh blogs at blog.hasmanythrough.com. Last time I looked, he was still number 51 on the committers list for Ruby on Rails. And is an all-around smart guy. He tweets at Josh Susser. That's JOSHSUSSER. And welcome to the podcast, Josh.
Thanks. You can tell I have to work on my Rails contributions. Get in the top 50.
There you go. And finally, we have Avdi Grimm. He is the author of Exceptional Ruby. You can find that at exceptionalruby.com. He also blogs at avdi.org/devblog and tweets at Avdi. Welcome, Avdi.
Hello again.
And I realize I keep saying Avdi. Is it Avdi or Avdi?
It is Avdi.
Okay. And I'm Charles Max Wood. I'm the host of the Teach Me to Code podcast and screencasts. I'm also the host of the Rails Coach podcast. I do Ruby on Rails coaching, and I am preparing for a Ruby on Rails course that will be held July 26th that you can sign up for at teachmetocodeacademy.com. And this week we're going to be talking about personal design coding practices and patterns. It was a topic that was suggested by our illustrious Josh Susser, and so I'm going to let Josh take it away and explain exactly what he meant and give us some ideas of what some good practices are.
Okay. So I started compiling a personal list of design rules longer ago than I care to admit. And you read things like premature optimization is the root of all evil, and there's only two hard things in computer science: naming things, cache invalidation, and off by one errors. So, I thought I should write down the ones that seem to make sense to me and keep them handy when I'm thinking about hard problems or even easy problems, I guess. So I have a few of these rules that I've acquired over the years, and I expect that most programmers do, whether they write them down or not. So that's just where I came from with my suggestion.
So, Josh, you give this list to potential girlfriends, or?
No. I don't.
Design rules must have own 32-bit stack.
Yeah, I don't think there's any design rules that work for relationships.
I see.
But coding, luckily, is much simpler. So.
What are you talking about? There's HAZA, there's collaborates with, there's... Oh boy, crickets are going loud.
All right, so tell us some of your favorite personal design rules, Josh.
Okay, so I have mostly these things are about context and so a framework for thinking about things. So premature optimization is the root of all evil is a great example of that, I think. And just because these are personal design rules doesn't mean that I was the one who thought of them or I'm the only one who uses them. Mm-hmm. I think that premature optimization one is great. It's something that everyone takes to heart because you've gotten into a situation where you tried to make everything fast first before you made it work right, and then you're screwed. So I don't know if we have to talk about that rule at all, although there's a lot of people who like to counter it with post-mature optimization is also pretty evil.
I have a favorite comment that I like to point out to people is that it is a lot easier to optimize correct code than it is to correct optimized code.
No, well done.
So, premature optimization, is that the same or similar to Yagni? You ain't gonna need it?
Sometimes.
Yeah, in a way. I think that the idea is that, if you spend... I think the main thing behind premature optimization is that computers are really hard to predict, right? And if you try to guess where the time is actually being spent, a lot of times you just guess wrong, right? Like you spend a lot of effort optimizing that one function, and it turns out that's not where the majority of the time was being spent. So good on you, but you didn't really do much, and optimizing that 1% of the system versus the 90% of the system didn't do much for you.
Yeah.
And the effort put in there. So I think it has to do with, first of all, you shouldn't do it until you really need to, right? Because the idea being that until it's, slow enough that somebody notices, who cares? If you're using a construct that's, 3 times as slow as one you could be using, but it's still much faster than I blink, who cares, right? I mean, if it's not causing you problems, then it doesn't necessarily matter. And then when it does, you can find the right part to actually go in and optimize, which, we all know that adding something like a cache or whatever typically complicates things, so.
Mm-hmm. I have two things to add to that, to extend that thought, which is the first one is, and this is just a quote from, I want to say, Steve McConnell in Code Complete, which is that you never, ever, ever optimize without taking measurements, because if you fiddle with it and it seems faster, the only thing you know for sure is that the code is now harder to read. And the second thing is that I see programmers all the time who will just over and over and over, premature optimization is the root of all evil, premature optimization is the root of all evil, and then they will sit down and they will say, we can't do it this way, it's too slow. And I push back on them and say, premature optimization is premature until you have a requirement and a standard. If you can't tell me how slow is too slow, if you can't tell me, now if you're writing BOGO sort, it's obligatorily stupid. I mean, there's a difference between the simplest thing and the stupidest thing that could possibly work. But until you actually have a requirement that this needs to return in 800 milliseconds, don't optimize it. Just write it. The chances are that it's something that it's a loop that it's a loop that runs 10,000 times, but it only runs when you start the server and never gets run again. You know what? You don't need to optimize that.
Mm. I think another angle of that I've seen over and over again is like, when a programmer first learns, the proper way to cache something, you show them how you would use memcache to get something out of memory, or you show them how you use Rails caching actions, so you can cache a Rails action or something. You show them that, and then typically they'll have that reaction of, oh my God, I'll just cache this whole thing, and they go through and cache like 500 pages, and then they're surprised when their app gets slower, right? Mm-hmm. But, I mean, when you think about it, it's almost obvious, right? I mean, caching, by definition, slows something down. Because before, you were doing some work, returning a result. Now you're doing some work, saving the work, returning a result. You're doing more things, right? So it's got to get slower. But the advantage is that we hope to make it up over time in future steps when we can skip the doing some work part, right, and get faster. But I think that's the point, is that, like, if you just throw optimization at a problem, then what do they always say about regular expressions? Now you have 2 problems, right?
I think the only place that I've seen where premature optimization might make a little sense is at a high level, a high architectural level. So when you write a CMS and then belatedly realize that what you were actually trying to create was a messaging system, which is what Twitter realized, that's a case where maybe a little bit more thought about the architecture up front might have been a good premature optimization. I mean, you can often say some things with reasonable certainty about certain high-level architectural patterns. Now, what this doesn't mean is you can't just say, oh, we're going to use MongoDB because it's faster, or so whatever. I'm not picking specifically on Mongo, whatever, NoSQL database or whatever. That those decisions tend to be a bit more. They can be a little overblown, but I think there is a case to be made for saying, it's been observed that certain types of systems work well when they're scale well when they're architected certain ways, and don't scale so well when they're not architected those ways.
So I think you've got a good point there about kind of picking data structures that model your data better. Like, for example, I mean,
Well, you just cut out James. I'm gonna step.
Go ahead.
I'm gonna step in really quickly. I did get a mention on Twitter by Fred Lee. He said that if you guys, and myself included, could every so often just say, "This is Chuck," or whoever, and then make your point. He said that it's kind of hard to follow who all the voices are. So
that's a good point. Do I have to introduce myself as the real James Gray, though?
If it makes you feel better.
So this is Donald Duck. And what I was saying is, I think that Avdi's talking about, choosing right data structures, and that, like, you sometimes get the SQL structure being our default because it's a general tool that does okay in a lot of areas. But there's some areas where plain flat file storage on a file system is going to way outperform it depending on your needs. If you had some hierarchical setup and that's all you needed, where a folder structure maps beautifully to it, or something like that. So that you can get yourself pretty far down that data hole if you choose the wrong system, right?
I will add to that. This is David, or the imaginary James. The premature optimization is the root of all evil. If that's true, then premature implementation is the trunk. And another design rule I have is always relentlessly be top down whenever possible. Don't be bottom up. And I've recently, like in the past week, come to realize that Rails is one of the most perniciously evil frameworks in that regard. Because what do? You go to your stakeholders, you draw pictures, you get screenshots, you get these lovely little PSDs of how the web pages are going to work, and you have this very high-level architecture about the whole system is going to work. And then what do you do with Rails? You sit down and you type Rails generate migration. You have just chosen a SQL implementation. You have just completely end run. You were up here at the top level, and you went immediately to the bottommost level of your data, and now you're going to try and build up from there. And boy, I sure hope you come up when you finally break the surface. I sure hope the tip of your iceberg is inside the circle of the app that you were supposed to build. And premature implementation is just a bad idea. If you need transactional data. If that really is what you're doing is transactional operations, you need to be doing SQL. But if an object graph is more important, you should be using a document database or an object database. And if reporting is really what you're doing 90% of the time, you need to put on your big boy pants and look at columnar stores or data warehouses.
Yeah.
So to go a different way with that, what about rule number 2, don't do big upfront design?
The top-down answers that, right? If you stay at the top-down, if you basically say, I need a web page that's going to show me all of my, I've got a thing that's shooting latitude and longitude and time out of my phone every 60 seconds, and I need to look at that. If you say relentlessly top-down, your first 2 or 3 iterations, you don't have a storage model. You don't have objects being persisted anywhere. You've just got a web page that shows things. And this is some of the craziness I'm getting from Smalltalk, which is that, until you actually have a requirement to persist stuff when the server goes down, just keep them in memory. Okay, I realize I'm talking really crazy stuff now, but
it's not crazy.
Okay,
I've been advocating that. I've been advocating that for a while. Start out with pure domain objects, and this is Avdi, by the way. Start out. There's nothing in Rails that says you have to stick active record thingies in that model directory. Mm-hmm. Start out with objects. Classic OO. Model your domain in objects, and then once you hit the point where we need to start talking about persisting this stuff, and that might be an iteration in. then start adding active record to those models. And the neat side effect of that is that you'll actually wind up with simpler tests because you won't be you won't be stubbing out a lot of active record stuff like that.
Yeah, there's a specific code smell / pain point, and Shiny Systems has a client right now. I'm already referring to myself as a company. I love it. Anyway, sorry, this is a new experience for me. But I have a client right now that is experiencing this exact pain point. They designed the database. They designed a very intricate, polymorphic system, and then they had to go write their own special active record search methods and search optimized query generation to search this thing. And I sat down and said, okay, let's write an acceptance test. Let's actually make sure that when we pull up the price of this product in this store, that it actually gets realized correctly to show up in this store at the correct price. And we found that at the acceptance test level, it was almost impossible to do. It was extremely painful to map this searching system up into the domain. And so, yeah, if you just start at the top and work your way down, there certainly are some pain points that you run into right quick, which is that you've been coding this way for 10 years. You're used to persisting everything in a relational database, and the tools are there, and the top-down tools aren't all there. There's some new ground that we're breaking, which is sad because this idea is really old. So, anyway.
Yep.
So how do you strike the balance of knowing when we're doing too much upfront, which is leading more toward big upfront design and less toward being agile, as opposed to when we need to do more upfront? How do you get a feel for when to do those?
For me, it's a matter of just knowing why you're doing something. Who's going to use this and why do they want it? And if you know who's going to use it, but not why they want it, you might not have enough big design up front. You might be so agile that you're acting stupid, that you're acting inefficiently. But if you know why they want it, it's okay in agile to look one or two iterations ahead and kind of know where we're going with this thing. That's my thought. Anybody else want to take it?
Well, it seems like in a lot of cases, people do a lot of big upfront design, meaning that they basically outline how the entire system is going to work. They get up and they say, okay, so I need to be able to post a tweet, which means that I need a tweet model and I need a tweets controller, and the tweets controller needs to handle these couple of cases and then pass it off to the tweets model that's going to do all this stuff. And yeah, that's way too much. That's a lot of big upfront design that just really doesn't have to happen. However, if you are kind of taking it a step at a time, where you're starting at the outside and you're saying, I need a form that I can put a tweet into, and when I click send, it shows up on my feed, and then your next feature is, okay, yeah, when the server goes down and comes back up, I need that tweet to still be there. And so you're really not doing a lot of upfront design, even though you're starting from the top and working your way in. What you're really doing is you're saying, okay, one step at a time, I need to be able to post a tweet and I need it to show up, and so relatively simple, you're starting from the top or from the outside and working your way in, but you're not necessarily doing a bunch of upfront design.
Yeah, in the sentence you said there, in your first example, you didn't get in trouble until you said how. I want to send a tweet, and here's how we're going to do it. That's where you ran into trouble, and you start moving away from top down to what I call bottom up on stilts, which is that you're still pretending to do top down, but you've already thought very quickly in your head that you're going to use SQL, you're going to use a polymorphic join, you're going to do and so the very next top down thing you do is you start saying, we're going to handle these objects by ID. And wait, what do you mean by ID? Because you've already designed this as a SQL relational database solution in your head. You're not doing top down anymore. You've silently done bottom up.
Well,
right.
So I don't think that's generally, or that's always a bad thing, because if you have done that sort of thing before, it's a natural reflex to say, okay, I know how to do this in SQL, and this is what I'm going to do. But you know how to do it, so the problems that you run into doing that, you're going to already know how to deal with them. So it's not, I think, always a bad thing to do that kind of design.
Actually, I think you're dead on the money. You know, the key differentiator between when waterfall works and when agile doesn't is, have you built this exact same product before?
Yeah.
If you have, then you can do waterfall because you actually know how to estimate everything. And I'm taking it to an extreme, but I think you're right that, you know, if you've built this system or this style of a system, you can steal pieces that you built before. Sure, there's pre-factoring that can go on realistically. It's just one taken to an extreme, I think.
Right, and I was going to go ahead. This is Chuck. I was going to go ahead and make the point that you know, I've built a house before, let's say, and I know how that works. So I get in and I start pouring the foundation, you know, with cement, and, you know, I do all the other stuff that I'm supposed to do. But if I'm building a house in the Philippines and it has to deal with a monsoon, I don't want it to get flooded every time. So as long as I'm somewhere where I know that that's the kind of house that I need to build, you know, or in the case, I know how to build a house for this area, then it's okay for me to go ahead and start at the bottom, pour the foundation, and just work my way up because I know how it goes together. I know what all the parts are. I know what's in the blueprint, and, you know, and it's nothing foreign to me. But, you know, as soon as you get into anything that's different, anything that you haven't done before, that you don't really necessarily have the experience to draw upon to say that's how it needs to go, then you're better off, you know, meeting the requirement and then figuring out how to implement it.
Right. The key.
Sorry, I was just going to say we've been talking a long time kind of about premature optimization, and maybe we want to try talking about other design rules. Seems like we spent all on one thing.
I was thinking that we had kind of shifted rules. Like, for example, it seems like now we're talking a lot about top to bottom, top down or bottom up design, and whether or not that's a good thing. But one interesting thing I kind of thought Chuck shifted it in his discussion when he had that example where he got stuck thinking through the abstract implementation and he shifted back to the user interface to refocus. He went back to, you know, I need this form here where a user can put a tweet in. Which is an interesting thing because I've noticed more and more lately that when I'm designing web applications, I begin at the URLs. That I like start mapping each individual URL to where it goes. And like, I'm sure other Rails programmers would hate to work with me right now because I don't think I use any Rails routing features the way they're meant to be used anymore. Because I always try to fit the URLs to exactly what I think they should be, which means I typically get away from the boring resource routing and stuff. But it was interesting on, I think we kind of got into, you know, what is the focus of design? What's the focal point? And it seems to be, you know, sometimes it can be this, sometimes it can be that, and how do we know what that is?
That's actually a really good point. That what I started making a list of kind of what my design rules were, and in preparation for the call, and I actually came up with some meta rules. And the last one I wrote on there is try to always be open to your design rule not applying in this situation, or just flat being wrong. I have been a very bottom-up structured programming type programmer for 20 years, and I've always felt that that's the way to do it, and it's very easy for me to go to a whiteboard and begin talking about an application by drawing an entity relationship diagram and mapping the database and building up. And it's been painful for 20 years, and it wasn't until I started getting into object thinking and Smalltalk that I started realizing this is why this hurts. And it was a really difficult ego moment for me to realize that everything you know is wrong. Everything everything you've based a 20-year career on has a fundamental assumption in it that is wrong, and you have to change that. And you have to be open to, you know, this particular design rule might actually be wrong. So how do you implement that? I have a really simple thing, and that's go for a walk. Be willing to just back away. You know, James, you like to map everything out in, you know, URLs, but you're going to end up at a pain point someday when your URL is localhost :/kernel/lambda, and then you've got an expression that your website can parse. That's time to step away from the keyboard and just, you know, kind of clear your head a little bit. I was recently doing a to-do application, you know, for like Pomodoro timing, and so Pomodoro is it's absolutely centered around the concept of this 25-minute Pomodoro, 5-minute break. And so, of course, the most important object in the system is the timer. So we sat down and we started writing the timer. And just the app, we just could not get this thing to make heads or tails or heads or tails. And we finally went for a walk and we came back and we realized the timer is like the least important thing in this. You could build this entire system with no timer and just make the user carry a watch. The most important thing is, what do I need to be working on right now, and is it done? And as soon as we chased this for like 6 hours trying to build this stupid timer, and then we realized, no, it's actually figure out the workflow, and then the timer gets really stupid easy, because at the end of 25 minutes you mark off a Pomodoro and you're done. And you've already built the ability to mark off a thing. So anyway, yeah, be willing to walk away, clear your head, and get a new idea, come back fresh.
So what about another rule? Getting back to Josh's idea, who's got a design rule that they live or die by?
I have another one I can throw out there, that just to maybe direct things.
Go for it.
This is something I cribbed from Alan Kay, and Alan said, "Make simple things simple and complex things possible."
It's a good Ruby rule.
Yes, and I like to say, I noticed a while ago that Apple Computer used to be really good at this, back when they were Apple Computer. Now they're just Apple, and they're really good at make simple things simple, but they've kind of given up on the complex things possible. So it's no longer the day where you can hold down the Option key and get the extra features on the menu.
That's interesting.
That's a good example.
Yep.
Although, as a counterexample, I have a piece of hardware I'm using right now that requires a 32-bit driver. And on this, brand spanking new MacBook Pro, I was impressed that I could reboot it and hold down the 3 and 2 keys while it rebooted to get into 32-bit mode. So, some of it's still there, I guess.
No, I don't know. I think that might just be making complex things obscure.
Yeah. Yeah, because what they don't tell you is if you do it backwards, you will boot into 23-bit mode.
All right, so I have a question about that as far as make simple things simple and complex things possible. There are a couple of things that are kind of wrapped up in that aren't necessarily simple. And one of them is first, how do you recognize when things are simple and when they're not simple? And how complex does it have to be complex?
Very subjective things. I think the rule or the takeaway I always use for that one is, if I'm a user and I'm going to want to go into your site and do X, and you make me click 5 times just to do that, or answer a few arbitrary questions along the way, then you're missing the simple path, right? That you know why I came, you know what I'm after, and you're harassing me to get there, right? Is kind of how I view that one. And libraries, I want my libraries to function the same way. Like, most of the time I just want to use the library like this. There may be some rare circumstances where I need to crack the whole thing open and be weird with it, and let me do that, and it's fine to make me suffer for that. But that most of the time I just want the simple, smooth interface that solves my most common need.
Yeah, I think that Rails routing is actually a pretty good example of this. I think done pretty well. That the things that are straightforward that you do over and over again, like RESTful routes, are really simple to set up. You just say resources, users, and you're done. And then there's a whole bunch of other options you can throw on your routes to generate really complicated things that aren't going to be as common.
Mm-hmm. Right.
I have a couple of ideas for how to translate that down to actual code. If you guys are interested,
that was my next question, so go ahead.
Okay, perfect. So, and I'll just start and then throw it out to the rest of the group. One real obvious thing is that if you're going to write the each method in Ruby, you should also probably write the map method, because there's going to be one person who wants to hand you a block and iterate over the thing, and then there's somebody who just wants to get the freaking collection. And if you write each and you don't write map, you've now forced them to create an array. Each yields into the array and just append.
Well, that's what enumerable gives you.
So enumerable gets that for you now. But I'm working with some code right now where they're not using enumerable. They've got, literally this long function that begins with each thing is this and this and this. And it's this really weird, complicated object that's like 5 levels deep. I tweeted a screenshot of actual code in which I basically had at plan dot first dot second dot first dot second dot cost. And it was basically this huge anonymous data structure that was all positional. And I'm like, we need to start doing some name calling in here. And so basically, if you write methods to be accessed in kind of a left-handed fashion, write the right-handed method as well, so that you're not forcing people into, because sometimes map is simpler than each. Avdi's right, so that enumerable gives that to you, and I can't think of a good non-enumerable example.
Right. I mean, you should be able to inject enumerable into that object and then have a map for free.
Right, object extend enumerable. And in a way, I think that's kind of an excellent example of the rule we're currently discussing. I mean, that's kind of one of the points of enumerable, that if you do the each method and then include extend enumerable, whatever, then you get all of the normal iteration things, the normal things that we always do in iteration, those simple things, you get those for free.
Yeah. The other thing that I found to make code simple, or to keep simple code simple, and this is actually a revelation to me. Again, I came from a structured proceduralist, formalist background, and so I'm not afraid of long methods. I'm not afraid of large classes that do too much. And I had just a splendid argument with Uncle Bob a while back, where he was basically saying short methods, small classes that only do one thing. And I said, all you're really doing is you're taking the complexity of the system out of this particular object, and you're pushing it up into the space, into the interstices between. You've now got 15 classes that do what this one class did, and the interaction between these is now hiding some complexity. And he kind of squinted and he said, kind of, but not really. And what I'm finding is I'm getting into small talk and into this object thinking is he's right, I'm wrong, that was FUD. If you are afraid of pushing complexity up into the interstices between objects by making small objects, you need to go read object thinking, and you need to just sit down, shut up, and do it right, because it just doesn't happen.
So I agree with Bob on that. This is Avdi. But at the same time, I wrote a post a while back called